operators. Okay? Good, hands good. Smart. Okay, so for relational operators, we have a fact pen. You must have seen these equal to sign, greater than, less than, exclamation mark equal to, greater than, equal to, less than, equal to. For logical operators, we have this ampersand, ampersand, two dots, I don't know what they are called, and an exclamation mark. And for arithmetic operations, we have plus, minus, multiplication, divide, and this is called a modulus operator. Okay, so when we are doing conditionals or loops, what we are trying to see is, do we want to do this or do we not want to do this? So for that, what we need is, we need a condition. A condition tells us whether it is true or it is false. Okay, and true usually means 1 if we are talking about binary, and false would mean 0. But when we are coding, anything that is not 0 is also then considered to be true, and false therefore stays as 0. Okay, so what are we trying to do? A condition that gives us whether something is true or false. So conditions can simply be, let's say we have a variable called x of long type, and we say, is the variable and x equal to 5, and we say x is greater than 5, greater than 6. So is x greater than 6? No. Right? So that means it's false. Right? So let's have an example now that you know about the condition. Before that, we have this relational operator called equal to equal to. So there's equal to simply, and there is equal to equal to. What this means is, whatever container you have over here, any variable, let's say x, will have the value of whatever you write over here, right? So in this case, if we write 5, then x will have the value 5. Okay, but equal to means that the value over here should be equal to the value over here. If it is true, if it is the same, that means it's true. If it is not, otherwise it's false. So this way we are giving a condition. So I have a question now. Let's say we have a few variables called long, x equal to 77, y equal to 66, and z equal to 66. Okay, any random number. Okay, so x equal to y equal to z. Can anyone tell me what the value of x is? Say it louder. The value of x. No.
66.
No.
0.
No.
77.
No.
Oh. No.
No. 1. Okay, so what we are doing, whenever we are calculating, we calculate first thing what is in the bracket, right? And whatever this value will be goes into the container, right? So what was this? This means this thing has to be equal to this thing. This is 66, this is 66. It is?
Yes, sir.
Equal. That means true. True means?
1.
So x will be 1. Okay. Similarly, you have a variable, again, x. Give me a number.
30. 30. 30.
Okay. If I had to print this, so much of writing, print s, SED out, percentage LD, and we're printing x. If we do this, the output will be 3. If I had to print this, what would be the output? Oh, by the way, the logical operators. Do you, you're EE, right? EE or ECE? Which department? Huh? So you must be knowing logical operators, right? What is this? You know, like and then or not. You do that in like circuits. You know that, right? So circuits are also about true, false, and everything. So whenever we learn to make a truth table, right? So we say, okay, what we're trying to do is we're trying to learn about the AND operators, right? So if we have a true and we have a true, what happens? It's true. If we have a true, we have a false, false, and false true, false. Okay, simple. You know the logic. How about true or false? True. But what about not of true? What is it? False, right? So how would you say that? You would just simply say, okay, this is just a representation, okay? This would mean false, right? So if printing x was 3, what would be if you print not of x? 0. Good. Awesome, Luca.
Yes.
0, right? And okay, what if x was 1? Then yes, still 0. Easy question. Yes. So basically, what I'm trying to say is, you will get to know that. What if x was 0? Yes, it will be 1. So again, through this we understand that any value other than 0 is a true value, okay? And 0 is basically false. So we're trying to put up a condition. Any condition is a greater than that. Is it equal to, or are both the sides equal or not? If it is not equal to, this is the opposite of this, right? If it is greater than equal to. So we're trying to have a condition. And if we want to have two conditions, we can have some logical operators, right? And then we can do some arithmetic operations to do some calculations. So whenever we're doing loops or conditionals, what we need is a condition. Going to the next thing. Now, this is something that I like a lot, but we don't really use that. We don't use it so much. But just to get a logic. Again, what I'm trying to teach is what you would say logic, okay? Or I would say playing with programming. So you don't really need to be like, I don't know, I haven't passed milestone 3, I don't know coding. This is just understanding. You can still understand, okay? So let's say we have a variable called x, and we don't know the value of it right now, and we have a variable called y, and the value is 2, okay? So if we had to calculate x modulus y, by the way, modulus means remainder. Remainder. What is the remainder? What is the remainder of this? Good. What is the remainder of this? What is the remainder of my hand is so black? 2. Good. Okay. So you're getting the remainder. But what is this if we are doing long calculation in long? 2. If we were doing calculation in double, then what do you mean 2 point something? We are Asians, we're smart in math, come on. Good, 2.5, not 2 point something. Okay, so we do some calculation. Okay, so x is any number. Give me a number, this side. Number? 5. 5, good. Okay, so 5 modulus 2 will give you 1. Okay. What if I increase the value of x? Okay. Let's say we did x plus plus. Okay, so 6 modulus 2,
0.
0. Okay, so if I am increasing x, the possible values are 0 or 1, right? So let's say now our the value of y is 3. Okay, now x modulus y. Give me a value of x.
0, 1, 2. Oh,
1 and
3 billion.
write it down.
Oh, I think.
How many zeros in a billion?
No.
Think before you speak. Okay, give me a number. Good. Okay. So 4 modulus 3 is
1.
1. Good.
Easy.
Let's say we increase the number. 5 modulus 3 is?
2.
Okay. Let's say we increase the number.
0.
0. So what are the possible values? Okay. So from this, what we understand in a logic wise is that any number modulus y, the value would range between 0 and y minus 1. Okay, so this way you can just have numbers between a certain number. And right now you don't know where you can apply this, but I will tell you where you can apply this. So next thing, now that we have understood what a condition is, we can now start learning about using if. Give me a number. Peter.
2.
You're slow. Okay. Not equal to 2. Okay. So now I want to see. Really? Okay. So is this true or false? True. Simply. How about this? How about yes? And if I am making a condition like this, what am I checking? Let's say it's any number. With this condition, what can I check? Yeah, what can we check? What's your name?
Stanley.
Stanley, what can we
You
check?
told me the answer, but I think wrong. So.
If we are getting a remainder with 2, we can check if the number is even or odd. If this is true, this means it's even.
Even.
If it is false, that means it's odd. Okay, so for checking if any number is odd, for checking if any number is even, condition. Okay, next one. Is this condition true? Yes.
Yes.
What about this condition? False.
False.
Yes. Good. Okay. So now you understand what conditions look like. So we can go to something more beautiful that I like, and that is loops. Okay. So why do we use loops? So that we are lazy and we want to do things again and again, and we don't want to type. Right? Just like gravity, we have a file, we put the file, it does the work for us. We don't have to type it one by one. Okay, what is H1, what is T1? Okay, so we do loops. So I'll write 2 simple loops so that you can understand. I'm going to talk about 2 loops, for and while only right now. Okay, so for, I'm not writing the whole code, I'm just writing the part that is important. Kimmy, how about you come here? Come here. I mean, you can come over here so that you can see clearly. It's hard to see over here, I think, this part. Okay, long I equal to 1, I is less than equal to 5, I plus plus. So does anyone know what we are doing with this?
What do you think so far?
Good. What about now?
What do you think so far?
Good. Okay, so you understand the difference. If it is this, we're doing 1, 2, 3, 4, 5. But if it is this, till 4. Okay. Now, how does this go? It initializes a value. Okay, I'll tell that later. And now I'm going to write a while loop. So we use while when we don't have any initialization, when we just want to check the condition, right? But if you want to look at for and while side by side, they're similar. You can use whatever you want. And we can look at the syntax for this. So for loop, what we're trying to see is we're trying to initialize a variable. We need to put a condition to check when to stop, and then we have a certain increment. Okay, and we do something over here. For while, what we're doing is, if we were to change this code into while, what we would do is we would do the initialization first. Then we would put the condition in the while. And inside the loop, we would do something, and then we would do the increment. Okay, so it's similar. Now, how does this go? It's like, how do we calculate? So I is equal to 1. Then we check the condition. Is 1 less than equal to 5? Yes. Do this. Now, when we go back, we increase I. Now the value becomes 2. Is 2 less than equal to 5? Yes. Do the work. Again, increase. Now 3. Okay. Is it? Yes. Do the work. Again. Now it becomes 4. Is it less than equal to 5? Yes. Do the work. Go back again. 5 is yes. 5 is less than equal to yes. Do it. Now when it becomes 6,
No.
the condition is?
Papa.
So we stop. Okay. Now this is where the fun begins. I like that. So now that you understand 4, we can play with 4. Okay, so I is 1. What are the numbers?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Good. What are we printing?
1, 3, 5, 7, 9.
Good. What are we printing?
2, 4, 6, 8.
Good. What are we printing?
1, 4, 7.
So we can do different things, okay? Just to play around to understand how loops are happening. So this way we can say we are printing the first 5 even numbers, right? This way we can say we're printing the first 5 odd numbers, right? Let's say we want to say we want the sum of first 5 numbers. Okay? 1 plus 2 plus 3 plus 4 plus 5. Okay, so we have a simple loop. I'm not going to print anymore. And this is 5, okay. And we have a variable sum initialized to 0. Okay, and then we say sum equal to sum plus I. Okay, so what happens is sum, okay, remember anything before the equal to is a container. It has no identity, it has no value right now. Whatever the value that it will have is whatever we calculate on this side. Okay, so sum at this moment is 0. 0 plus 1?
1.
Okay, so in the first loop, 1. Then Next loop, the value of sum is
1,
1. Okay, 1 plus
2,
2. That is
3,
I has become 2 now. Okay, so 1 plus 2, 3. Next loop, the value of sum is
3,
I has become
3, 6,
okay. Next,
6, 4, 10, 5, 15, 15, 6, 21.
no,
Oh,
it stops. Okay.
yeah.
So what is the sum? Now calculate 1 plus 2 plus 3 plus 4 plus 5. What is it? What is it? I don't know. Time. 15? Yeah, it's 15.
Yeah.
You sure? Okay. Now let's say this was a variable called num. Okay. Simply, we're just calling it, we're just changing it. Okay. What if instead of plus I was doing this, multiply? What would happen? What is the answer?
0.
You sure?
Yes.
Why?
Because number is 0. 0 plus every number is always
It's going to
0.
be 0.
Yeah.
So, like, what would you do? What would you change now?
1.
This will be
1.
now we can multiply each number. Okay. Okay, so another thing that we can do that we have, so instead of going like increasing 1, 2, 3, 4, we can also go back, right? So let's say I is 10. Okay, we're not using long anymore. We're just playing with this right now. We're saying, forget this. You guys tell me. I equal to how much? What is the condition? And what is the increment or decrement? I want to print 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. How would I do that? I equal to 10. Okay, good.
Bigger and big or equal to 1.
So I should be greater than equal to
1.
good. And
Minus, minus.
I minus minus. Good. What should I change?
Bigger and greater and equal to 0.
Good. Okay. Now, if I was to say that, what if I make this this? Now what am I getting?
8, 6, 4, 2, 0, 0.
Yeah. Alright. And now one interesting thing that we can use remainders for. Give me a big number.
1 trillion.
How many zeros in a trillion? How many in a billion?
12. 是吗？是吗？是几个？啊？
Okay, Bill. Give me a number. Yeah, sorry, Bill, Hank. Paul. Paul? Okay. Bill, give me a number. Change. No back to Kevin, give me a number. Give me a bigger number. Okay. Okay, let's make it 51. Okay. So what would happen if we were to divide 51 by 10?
1. 5.
Huh?
5.
No, the number is long.
5.
5. No, if it was double, you would get 5.1. But this is long, so 5. Rounds down. Okay. And what would happen if it was this?
1.
1. Right? So let's say I give you a number 1, 2, 3, 4, and I say print each of these numbers, how would you do that? If you had a number 1, 2, 3, 4 and you divide it by 10, what do you get?
1, 10.
But if you had to do this, what do you get? So if you did this, you got the last number, then you did this, you would get now 123, and you did this 3. So you're getting another number. Now, what do you get?
12.
12. Okay, again 12.
2.
So you understand? Now you can get each number. What if I tell you, I give you a number and you have to add each of these? But right now I'm doing it manually. You can do this enough. Okay, so this is somewhere you can make it with the remainder. Okay, just for fun. And of course, divide. And that is the end of the class. Thanks.